Hello and welcome. Today I want to share a personal story about how learning to program changed my brain, and I mean it in the best possible way. I'm going to take you through my journey from struggling with simple logic puzzles to feeling like coding unlocked new mental superpowers for me. Along the way, we'll look at some fascinating science and also just plain anecdotes from the tech world to back up what I felt have been happening in my head for 40 years. As Bill Gates once said, learning to write programs stretches your mind and helps you think better, creating new ways of thinking that are useful parts of life. I could not agree more. So, how has programming reshaped my thinking, my problem solving approach, and even my behavior? Let's dive in. I first started coding when I was about 12. I quickly learned that computers are the ultimate logic checkers. They do exactly what you tell them to do, not what you want them to do. I wrote my first program in a math class, and it was to solve quadratic equations. Early on, I'd write what I thought was a reasonable set of instructions, only to have the program behave oddly. It turned out my instructions were not as logical as I assumed. Bit by bit, programming trained me to think more systemically. You can't code, at least not for very long, without breaking problems into clear logical steps and handling abstract concepts very precisely. In fact, Steve Jobs famously believed that everybody should learn how to program a computer because it teaches you how to think. I found that to be a spot on thought. Programming really is like a gym for your logical mind. This isn't just a personal hunch. Research shows that learning to code can significantly sharpen our problem solving skills and reasoning skills. A 2023 meta analysis of dozens of studies found that teaching people coding had a large positive effect on general problem solving. In educational terms, the improvement was noticeable. In the study stats, it was an effect size of about 0.89, which is quite high. Coding practice also boosted planning skills and even aspects of memory and cognitive control. What does that mean in plain English? It means that in the process of learning to program, doesn't just teach you how to code, it teaches your brain a structured way of attacking problems. You learn to plan how to solve the problem, to think about how a process should go. You learn to anticipate and nip little issues in the bud, which requires mental discipline and inhibition to stray off impulses. Over time, I noticed this myself. I started approaching everyday problems from organizing my tasks to troubleshooting a broken appliance in a more methodical, step by step way, almost if I were writing a little program in my head. Programming also forces you to deal with abstraction. You build mental models on how a complex system works, and then you manipulate those models. One scholarly review put it nicely. Programming requires skills like decomposing, abstracting, iterating, and generalizing, which are a critical part of human cognition. In other words, when you learn to code, you practice in breaking big problems into little problems, decomposition, simplifying reality into a workable model or abstraction, refining through repetition or iteration, and spotting general principle, generalization. These are heavy-duty thinking skills that transfer to many areas of life. I felt it myself. After wrestling with abstract coding concepts and grappling with abstract ideas elsewhere, whether it's understanding an analogy of playing a long-term project with many moving parts, it is as if coding stretched my mind's abstraction muscle. Supporting this, one meta-study found that students who learned programming showed improved performance not just in coding tasks, but also in tasks of creative thinking, math, and reasoning. Debugging my programs is something that I've worked on since I indeed was 12. Debugging code taught me resilience, perseverance, and persistence. Any programming programmer will tell you that debugging, the process of finding and fixing errors in code, can be equal parts frustrating and rewarding. In my early days, a single bug with just one character possibly could send me into a spiral of doubt. But as I gained experience and life knowledge, I noticed something cool. I started approaching bugs not as roadblocks, but as challenges or puzzles. It's like my mindset shifted from, oh no, it broke, to, okay, challenge accepted. In fact, adopting a debugging mindset is something experts often recommend for life in general. There's a great quote from Brian Kerrigan, a legendary computer scientist, who joked, debugging is twice as hard as writing a program in the first place. So if you are as clever as you can be when you write it, you will ever debug it. That quote always makes me chuckle and also reminds me not to write needlessly convoluted code. The simpler the better has been my motto for a very long time in programming. But beyond the humor, it underlines a truth. Debugging requires intense focus and problem-solving skills, often more than writing the code in the first place. Sometimes you have to retrace your steps, test your assumptions, and often learn something new to fix a problem. Psychologists like Carol Dweck talk about the value of a growth mindset, seeing failures or mistakes as opportunities to learn rather than as defeats. Debugging, by necessity, cultivates exactly that. Every time my program did not work as intended, I had a choice: get frustrated or get curious and attack the issue head on. With practice, I learned more toward curiosity and get it done attitude. Interestingly, researchers have noted that bugs in software often come from chains of cognitive breakdowns, basically little mistakes in our thinking that over time compound and create bigger problems. Maybe I misunderstood how a function worked, or assumed a variable could never be zero, or something silly. Debugging, then, is about examining and correcting your own thinking. You fix the code by fixing your faulty assumptions. One of the biggest life lessons from debugging is not to fear mistakes. In coding, mistakes or bugs are literally how you learn. I remember accidentally deleting an entire folder of source code in my first job, a huge mistake. But after the initial panic, I treated it like a bug to fix. I owned up to it, I asked for help, figured out what I did wrong, embraced source control system, and all that experience taught me a valuable lesson. It was painful in the moment, but I gained a habit of learning from my mistakes. Many programmers share similar stories of catastrophic issues that became turning points in how they approach problems. The key is that debugging taught me perseverance, meaning I stick with a problem until I solve it. You can try one fix, another fix, things may or may not work. Over time, I got better at anticipating issues and preventing them, which is another life skill, proactive thinking. One Hacker News article quipped that good developers have strong opinions weakly held, meaning that we plan and code with confidence, but the moment evidence shows we're wrong, like a bug, we are willing to adjust and adopt completely different thought process. That flexibility is something I've applied outside of coding as well. All in all, debugging strengthened my mental endurance and taught me that very complex problem is solvable with enough patience and analysis and perseverance. Instead of feeling hopeless when things go wrong, I now channel my inner coder. Let's debug this. There is a stereotype that I sometimes encounter in the world that programming is all about rigid logic and zero creativity. Just math and logic rules. But in my experience, coding is incredibly creative. It's often about seeing patterns and envisioning something that isn't there yet. I like to say that coding is the closest thing we have to a superpower. You conjure up entire worlds of solutions out of nothing but ideas in your head. Over time, I found that my brain started to recognize certain patterns automatically. For example, I'd see a new problem at work and think, hey, this is similar to that other issue I solved some time ago. Let me see if I can reuse that approach. My mind was building a library of patterns, from algorithm to design solution to simply coding patterns. This pattern recognition ability grew stronger the more I coded, and even spilled into my everyday life. I might notice patterns in how I organize tasks or how I solve problems around me. Scientific findings back up the idea that programmers develop keen pattern recognition. In fact, brain imaging studies of expert programmers show something very fascinating. Seasoned coders have distinct brain activation patterns when reading or thinking about code that newbies don't. One study identified 7 brain regions that across the frontal, parietal, and temporal lobes that were especially tuned to expert programmers. In these regions, researchers could literally decode what kind of code the person was looking at from the brain activity alone. In simpler terms, the brains of coding experts have become specialized to recognize coding patterns and structures. That kind of blows my mind. It suggests that with enough practice, our brains physically rewire to become better at seeing patterns in code. At least in my personal experience, coding also feeds creativity. Initially, I thought programming is strictly logical, but I soon realized there are many ways to solve the same problem. Writing good code is as much as art as it is science. A fact highlighted by the title of Donald Knuth's famous book, The Art of Computer Programming. You craft solutions. You can make code that is brute force and clunky, or you can come up with a clever, elegant trick that accomplishes the same task with half the lines and simpler to read. I've spent hours tinkering with a piece of code, not because it didn't work, but because I knew I could refine it into something beautiful. Even historically, the link between programming and creativity is strong. Ada Lovelace, often celebrated as the world's first computer programmer back in 1800s, recognized the creative potential of computers before the actual computers existed. She imagined that a machine could compose music if programmed the right way. She essentially predicted generative AI and AI creativity centuries ahead. That vision required enormous creative leap. Modern programmers continue this tradition. Think of creativity in developing a video game. Personally, once I got with the basics of coding, I found it to be a playground for creativity. Psychologically, programming often puts me in a flow state. That is the zone of deep focus that artists and athletes talk about, where ideas come together almost effortlessly. In that state, I'm not just following the logical step. I'm experimenting, I'm playing and creating. What's more, research indicates that learning programming can enhance creative thinking in general. In one meta-analysis, students who learned to code showed improved creative thinking skills on many tasks outside of coding. From my own personal experience, I feel like I am a creative person and I, for example, enjoy music and I enjoy painting. I feel like those things had to have been affected by lifelong practice of coding. Another change that I noticed over time from programming is that my memory and how I construct mental models of things have improved. When you code, especially as projects get bigger and bigger, you end up holding a lot of information in your head. What is each function supposed to do? How do different parts of the system interact? How did I handle all the edge cases? It's a giant mental puzzle that I find myself keeping in my head. Neuroscience gives a really interesting explanation to this. When we engage in coding, our brain activates what's known as multiple demand network, the same network it uses for solving complex problems like different math or puzzles. This network spans regions in the frontal and parietal lobes that are known to be involved in holding pieces of information in mind and juggling them. Basically, the neural substrate of working memory. So reading and writing code is literally a workout for the brain's RAM, if you will. One MIT study found that reading code did not light up language areas as one could suspect. Instead, it lit up those multiple demand areas that handle logical reasoning and memory. The task of keeping track of variables, following a loop in your head, tracing a function logic, force you to hold multiple concepts at once in your mind and manipulate them mentally. It's no wonder that a study using brain scans confirmed a strong relationship between programming ability and working memory. Students with higher working memory capacity showed better programming performance. I've also developed what I'd call better mental models thanks to coding. A mental model is the representation of how you think something works. When programmer tackles a problem, we often start by mentally modeling the system. Through debugging and refining code, I got much better at building accurate and detailed mental models. I learned to ask myself, do I really understand how something works? If not, I would dive deeper until the picture was clear in my head. This habit carried over to other areas. For example, when learning a new skill or even learning how team functions at work, I actively construct a model in my mind. And thinking back, I found that, for example, I took that kind of reasoning and applied it to when I was learning how to shoot a handgun. Again, I created a mental model, I identified the areas of moving picture, and then I worked on the plan to improve. One of the most astonishing things that I've read recently is that learning to program can even lead to physical changes in the brain structure. A 2023 study took people with no coding experience, put them through a 15-week programming bootcamp, and did MRI scans before and after. The results showed increased gray matter in multiple brain regions associated with high-level cognitions, including parts of frontal lobes and even the cerebellum, which is often linked to coordinating complex sequences. The amount of growth in some of these areas correlated with how well the students learn to program. For instance, growth in the right frontal lobe, a region related to planning and goal management, was linked to better project performance, and changes in certain frontal and subcortical regions tied to problem solving and reward were linked to test scores. This is concrete evidence that programming doesn't change your mind metaphorically. It also changes your brain physically through science of neuroplasticity. When I read that, it gave me chills in a good way. It made me think that why I often feel different after years of coding. My brain quite literally got reorganized through the practice. You might not expect it, but programming also made me better at empathy and communication. That is, I would say, alongside with having a family and children. I know it sounds strange. Coding is famously associated with sitting alone in front of a screen, but the reality is, if you work in a big company, you're never alone. Over time, I realized that coding is not just for computers. Coding fundamentally is for people, for the next developer who's going to maintain my code, for the teammate who reviews it, or for the user that interacts with the software. This realization instilled a sense of empathy in me. I had to put myself in other shoes and ask, if someone else reads it, will it make sense to them or will they curse me? If a user clicks this button, is it going to do what they expect it to do? There is a well-known guideline in software development that programs must be written for people to read and only incidentally for machine to execute. In other words, code needs to be human-friendly. That quote from computer scientists Harold Abelson and Gerald Sussman hands in the back of my mind whenever I'm naming a variable or writing documentation. It reminds me that writing code is a form of communication and it uses a language that humans also use to talk to each other. Each identifier, each comment, a message for future readers of my software. This seems like small things, but collectively they require empathizing with an unknown person. You anticipate their questions or try to alleviate the confusion and preemptively address the issues they might see. Working on software teams further amplifies this. I participate in code reviews where others critique your code and you critique other codes. To do this well, I had to learn to communicate kindly and effectively, to give your feedback without offense and receive feedback without feeling personally attacked. I also learned to read someone else's code, deconstruct their thought process, almost like reading their mind. I also learned to understand that one problem can solve in a number of ways, and my way is not necessarily the only perfect way. So in programming, in my mind, there is no my way or highway in teams. Finally, coding has taught me patience in communication. Sometimes I'll talk to a newer programmer and they'll struggle with a concept that I find more or less straightforward. It reminds me of when I was new and my mentors in my first job in the United States helped me become a better developer. I'm trying to pay it forward and help the next generation. As we wrap up, I'm struck by just how much programming has transformed my thinking and even my approach to life. It started as a hobby or an exercise in my sixth grade math class. But later it became a job, something I get paid to do. Nonetheless, programming endured in reshaping me in the process. To recap this journey, programming trained me in logic and abstraction, making me think more structurally and more disciplined. It turned debugging from a painful trial and error slog into a mindful process of learning and perseverance. It taught me how to recognize patterns not only in programming but in the world. It stretched my memory and mental model building so I can manage complexity in my mind with more confidence. What is really amazing that all these changes are backed by science and stories from others. We saw that researchers have measured improvements in problem-solving ability and even observed the brain lighten up and changing in response to coding. We heard echoes of my experience in expert quotes and studies from Bill Gates and Steve Jobs, extolling coding's mind-expanding power, to brain scans show new neural connections forming as people code. It's reassuring to know that what felt like personal growth isn't just in my head, or really it is in my head. My brain today is not the same brain that typically wrote Hello World in my first computer class in college. If you're listening to this and considering learning how to code, or you're already a coder while wondering if those late night debugging sessions are doing anything for you besides giving you a headache, I hope my story and the insights we discuss give you a new perspective. Yes, programming can be hard and challenging. Sometimes it'll make your brain hurt. But that's exactly the point. Pain means your brain is growing. Just like exercise, the strain leads to strength. And you don't have to become a professional programmer to get these benefits. Even a casual dive into coding puzzles or small projects can help you improve your cognitive skills. On a personal note, I'm grateful of how programming changed me. It gave me not only a career I love, but also a mental toolkit for life. It taught me that the problems can never be too big if you try to break them down. The mistakes are just steps toward the solution. The understanding something deeply is worth the effort, and the empathy and communication amplify the impact of any technical skills. In a world that is getting much more tech driven by the day, having this kind of mindset is incredibly empowering. It's like having an insider secret. You know how to talk to machines and talk to people, how to systemically approach chaos and embrace creativity. Thank you for listening to my reflections on how programming has changed my brain. I hope you found some nuggets of insight or at least found the interesting story in here. Whether you are a seasoned coder, a newbie, or just someone curious about the intersection of tech and the mind, remember that every line of code is not just instructing a computer, it's also subtly instructing and reshaping you. Keep learning, stay curious, and happy coding. Until the next time, this is your host Sergey signing off. Slightly rewired for better by coded.